Welcome to my Puppet demo. The purpose of this demo is to show a different process for building, testing, and deploying Puppet modules. So I'm a software developer by profession and only recently became familiar with Puppet. I like what Puppet can do for me to set up machines for my application. But what I don't like is the process I have to go through to test and deploy Puppet changes. So, taking from my experience as a Java developer, this demo is how I would like to see and be able to build, test, and deploy Puppet code. I come at this process with two main goals in mind. First, the developer should be able to test without checking in code. I want a fast test cycle. I want to be able to quickly iterate on modifications and test them. Not having to check in code every time also helps keep my repository history clean. Number two, I want my Puppet code to live alongside my Java code. The Puppet code to set up my application should be checked in the same repository as my Java code. Having the code together is better organization, and it helps with running continuous integration, and I'll talk a little bit more about that later. Okay, let's have a look at my sample project. As you can see, I'm using IntelliJ here and with the Puppet plugin. And here's the structure of my project. As you can see, I've got Test Kitchen set up, and that'll help facilitate some of the testing that I'm going to do later. Puppet Builder is a table saw build script that makes this workflow possible. TableSaw uses Ivy to pull down dependencies and publish artifacts to and from a repository. I don't want to focus too much on the tools as I do the process, but I will explain what Ivy does for me in just a bit. Okay, right now my application is pretty simple. I've just got a main class. But I know that my application is going to require a network time protocol set as well as a MySQL server in order to run. This is where Puppet really comes in handy. I have a Puppet folder where I've added a metadata.json and my init.pp files. Let's start by adding the dependencies that I'm going to need for network time protocol and MySQL. I'm just going to cut and paste those from here and here. Okay. And now in init.pp, I'm going to include my class for network time protocol. And there. As you can see, IntelliJ is highlighted or is underlined NTP as marked as an error. This is because it cannot find the class defined in my project. Okay, now let's see what Ivy can do for me. Ivy has the ability to publish to multiple kinds of repositories. Previously I used Ivy to publish all my dependencies to a local file system repository which I will need for this project. So, to pull in my dependencies, I will use my TableSaw build script to retrieve those. Let's go to that. Okay. And this shows me all my targets. The one that I want is retrieve all. What this does is it converts, and this is in the script, the script converts my metadata.json dependencies into an XML that Ivy can read. Ivy then fetches those dependencies from the local repository and extracts them into my project. Okay, let's go ahead and run that now. Retrieve all. And done. Okay. Okay, this retrieved the modules and their transitive dependencies into a temporary folder in my project called modules. this folder does not get checked in to source control. And if we click back to IntelliJ, we can see it automatically pick up that folder right here. And here's MySQL NTP and the two transitive dependencies that were required by those modules. Okay, as you can see, NTP is no longer highlighted in red because IntelliJ can find it. I can also now use IntelliJ's Click Into feature by control clicking, and it jumps to that code within my project so I can see what's going on. Let's go back. Now let's add in MySQL. What I need here to my project. So I want to install MySQL. Oops, I got a wrong thing there. Server. And I kind of like to set the root password as well, but I can't remember what the variable names. But IntelliJ, I just type the first letter and it helps me out. I'm going to set the root password to nothing. And while we're at it, let's also create a database and set that up for my application as well. Well, DB, my app DB, that's my database. And for the database, I want to set the user. Set that my user. Oh, let's use single quotes, make it consistent. Let's set the password to something really original. And let's also restrict the host to localhost. Some of the nice things about this is now that I've got these variables, I actually can click and see into them and find out where they're being used. And I can say, oh, parameter user. And I can click into it and see which file that parameter or the variable comes from. IntelliJ can also tell me where these things are used from. I can find usages and see that they're used in my file as well as the MySQL modules and see wherever it is used inside of that module. It's pretty helpful. Having the dependencies in my project lets my IDE do a lot of work for me while I'm developing. Now it does still highlight these two as red. That's just because there's not an actual class definition for MySQL. It's more of a namespace holder. Okay, now let's test our code. And I have a couple of ways of doing that. In order to test, I need to get my module and my dependent modules over to a standalone Puppet server, either as a local VM or an instance in my lab. I like to use a local VM, as I can take snapshots and revert after testing the Puppet class. So I got a clean system every time I test with. So if I go back to my build script and run help, I have a target called package. This takes my module and all of its dependencies and zips them into a single artifact. Let's go ahead and run that. And take a look at that. We can see, let's take a look at my directory. So in my build directory, I created a bundle. We open that and you can see that I've got my application module and MySQL NTP staging and standard lib all packaged into a single artifact. This single artifact can then be copied to a test machine. I can extract it to then I can extract it and be used by Puppet. I can use this extracted bundle basically as if it were an environment when calling Puppet. The other way I have of testing is by using Test Kitchen. Let's converge on what I've done so far and see that run. So let's close this. Let's see. Converge. Let that start running. Okay, I paused the video so you wouldn't have to wait for that. As you can see, this took a while, mostly because this machine that I'm recording this video on is really, really slow. But it compiled the catalog and installed my MySQL server. But let's go verify just to make sure by logging into my server. So we can see MySQL is running right there. Let's try and log in without a password. That worked. And there's my database, myapp.db. Perfect. Okay, now that I've tested and I'm satisfied with my module, I need to publish both my module and the complete package out to my repository. But I wouldn't do that directly. I would have my build server do it for me. Now I'll use this diagram to kind of explain the rest of how this works. One thing is, though, I made this diagram a while ago and I've changed some of my terminology. So in here I reference classes and bundles, but that's really, I'm talking about modules and packages, where a package is multiple modules with dependencies put together. So anywhere it says bundles, I'm talking about packages, classes, modules. Okay, you get it. Once my code I've tested and I commit it to source control, probably a Jenkins, or then a build server, a build server picks that up from source control, and the build server is something like Jenkins. It picks it up and runs a build. Okay, what does a build consist? A build consists of pulling down dependencies from Nexus, because remember, the dependencies are not part of my source code. So Jenkins pulls down the dependencies, runs whatever tests I have, packages, signs my files, and then publishes 2 artifacts to Nexus. The first artifact is just my module, no dependencies. My module is what other projects would consume if they depend upon my app being on their server. Just like I was dependent upon MySQL, if somebody needed that, then they would just have a dependency upon my module. The second artifact is the package that contains my module and all my dependencies. This second package, or second artifact, is what Puppet then consumes. So once the package is published, the build server can then trigger an integration environment to pick up the change and apply them automatically. Okay, how would that work? Well, my first thought is to do it via an external node classifier. The external node classifier would look up in CMDB what version of the package is to be applied, and then look up that package inside of Nexus. Nexus provides file checksums and whatnot so that the file integrity can be checked, and it saves having to download the file more than once. So this should only happen one time. The ENC figures out what package and version, goes out to Nexus, does a HTTP request to pull down the file, and verifies it. The ENC would then extract the file and set the environment accordingly for the extracted package. So Puppet then runs normally. So the ENC, let's say for example my app version 1.0, it would create a folder underneath modules called my app 1.0, extracts the modules into that folder. Then it would tell Puppet that the environment is my app version or underscore 1.0, and then Puppet would just pick up all the classes that are in that folder and apply them to the server as normal. With this process, I haven't said if there's been a Puppet master or not. I think that should be optional. For developer tests, it definitely do not want a Puppet master, but it should be able to work either way. But there you have it. Thanks for watching.